So we are going to start the lab very soon. So this is the first lecture where we talk about a little bit about what we'll be doing in the lab. So far we have learned about plenty of instructions and we have been using in different quizzes. So this might be a great time to start the lab. So in the lab we use a board like this, which is called FOX11 trainer board. This is actually a complete computer. I'm sure that you know how the motherboard looks like, the main board of a PC, right? This is pretty similar to that one. This is not actually as powerful as we have in our computer in front of us, but this is pretty much we need for one complete computer, okay? So as you can see, we have plenty of different ICs and components here, and over the time we'll be learning about most of it. But at the very beginning, what we should look at is this is where we have our microprocessor, because as you all know that microprocessor is nothing but a chip, right? Which actually has some integrated circuits inside it. Not some, is plenty of integrated circuit inside it, and all the instructions you'll be writing and you are writing right now, in the quizzes and soon in the lab, in a compiler, is actually for this IC, this microprocessor, okay? And we have also several other things. Probably will not be exploring everything in this semester. For example, you see there is a breadboard, okay? So we'll be extensively using this breadboard next semester because we'll probably building some circuit and we'll show you how we can write the code to control those circuits, okay? Using the same instructions that we have right now, okay? Now, you can also see there are plenty of other things like some RAMs here and these are called ports, okay? So we'll know over the time what is what and how we use it, okay? Now, this lecture will cover some very basic things that we need to know for the lab. Now, let's look at some more components. Now, these are some additional components we have here which we need to know right now. For an example, there is a dip switch. This is pretty similar to the switch we have. Remember, in the digital circuit, we used to have a switch. This is exactly the similar switch. And using this switch, we actually control a port, which is called port C, okay? And I'm just, at this point, I'm not exploring. I'm just trying to give you the, the names and things a little bit from here and there, not everything. So we have a reset key here, which is like the reset button of our computer. When you press the reset, it basically starts booting from the beginning, and it again lowers all the software, booting software, especially the firmwares. This is pretty similar to the booting software. There is a power connector here, which we will be using with a 9-volt adapter, because this board runs as for a 9-volt power. Let me hand this pass it to you so that you can see the board, how it looks like closely. This is exactly the same board. And also we have 2 serial connectors here in this side, and using these 2 serial connectors we actually communicate with the computer, okay? So that means this board, this Fox trainer board, will be connected to the computer, the ones that we have in front of us. Will be connected to the computers, and in the computer we'll have a compiler. Remember when you did the C++ class, you had a compiler, right? Where which compiler you use? Is this the blue screen or the white screen? Is it Microsoft Visual C++, or it's just the regular Borland C++? Borland C++, okay? So whatever the programming language you use, there is a compiler, right? Where there is an environment, you type in the code, right? And you click some buttons, the programs get compiled, and it basically shows you the list of errors. If you have any, then based on that you fix the program, right? And you again keep run it. Once everything is compiled right, you run it. We pretty much will have a similar things here. So let me show you quickly what we will be doing in the lab again. So I'll be going over these steps as much as I can. Number 1, again, the purpose of this class is we'll be writing the code using the instructions we have. We have a 6-page instructions in front of us, and we have been exploring the instructions. We are trying to learn what means what, right? And we'll be using these instructions to write different programs, okay? Especially for this microprocessor that we have in the board, right? So you have to do something to use the board. So this is use the chip, microprocessor chip. So this board is something which allows us to access the microprocessor and use it using a software, okay? Which is pretty much like a compiler, okay? So we use that software and we'll compile whatever we are writing, right? And once we compile, what happens in C++? I'm always referring to C++ because my understanding is that's the only programming language we have learned in Southwest. So once you compile it, because you have all the assembly code, right, using the instructions that we have in front of us. Once you compile it, all the codes that we write, okay, gets converted into object code. Remember, we learned about the object code at the very beginning of this class, that how object code should look like, because all the object codes is just a bunch of binary numbers. I'm saying binary bits, okay? But we write it in hex. Remember, we gave you instruction, and you just wrote the object code for each of the instructions. And some of the instructions has object code of 1 byte, some instructions has 2 bytes, some instructions has object code of 3 bytes, right? That was, I think, which 2, right? So pretty much similarly, we'll have an object code generated, right? But what happens? Remember, this is what we are doing. We connect this board, Fox trainer board, with our computer, right? And in our computer, we have a software, let's say, okay? And we are writing the program actually in our computer, right? And once we write it, we compile it. Now, once we compile it, if it's compiled right, we'll get a bunch of object code, right? Meaning we'll probably get a file with all those object codes, right? That will be a file. Now, what happens? Once we have that file, we actually load the file. We actually call it downloading. We basically download that file from computer to this Fox trainer board, okay? Now, so look at this. We are writing everything in the computer. Once we compile it, all the object codes are here in the computer, right? Now, we actually want to run the object code here, right, for this microprocessor. So what we do is we basically download that code from the computer to this board. So there are memories, right? You can just think it as a computer, right? So there are memories, right? Just like how we see the memory locations in the memory map, in the quizzes. So we actually load download the object code into this Fox trainer board. Now, once we do that, we know that we already have written the code. We checked it because we have the compiler. Compiler already checked it. There is no compilation error, and that's why we have the object code generated. Once we have the object code, we downloaded the object code into the board. Now everything is ready for you to run. Then you actually run it. You run the object code. Now how do you run it? Again, using that software, because that software has a capability of writing the code, compiling the code, and also communicating with this code. Okay? That is a software which is designed for the Fox trainer board, and also is an assembly compiler. Okay? Let me show you a little bit about the software. This is what it will look like, because what happens is when you go to the lab, which is Fulton 370, when you go to the lab, you'll see we'll have a desktop icon, ASMID, which is actually the name of the software. Okay? Once you open the software, you will pretty much see a window like this. And this is where you will actually write the code. Do you see some similarity with the Borland C++ compiler? It's not probably as enhanced as you have seen in Borland C++, but this is pretty similar because these are the program lines. It will be automatically listing the lines, and you will be basically writing the lines one after one. We are not trying to understand all these lines here, but as you can see, some of the lines you know it, right? Look at this, LDS, LDX, you know these lines, right? LDAA, STA. We are not trying to understand all the lines, but I'm just trying to show you that how it should look like. And again, remember in C++, we write plenty of comments, right? For each of the program. what is the purpose of writing the comments? Just to make sure we understand it, somebody else understand it, or in case we write the program and probably after a month we forget. So just to make sure once we come back we understand what we did what. So similarly we can write comments here, but the C++, how you write the comment, there is a / right? Backslash once you actually start writing the comments. But here you start writing the comments using the semicolon. So everything you see with the starting with the semicolon are actually comments. You can always write the comments just whenever you need. You can always use a semicolon. You can write comments. Again, we have probably never talked about the comments. That's why I just mentioned. And in this window, we also have 2 tabs at the bottom. Do you see there are 2 tabs? One is called Messages tab, and another one is called Terminal tab. Okay. Now the Messages tab are the one once you write the program. Let's say you are here and you typed in all the program everything that you have. You just run the program and look at how you will have the extension. Remember the C++. What is the extension of the program? CPP, right? You remember? That has to be CPP, right? In our program, all the extension will be ASM because that's an assembly program. Okay. So it will be automatically ASM if you save it in the window here, right? Once you type it, you save it, and I will show you how you do all those steps one after one, okay? But once you run the program, you will see all the errors and all the list of programs. If you have any, everything will be coming in the messages window, okay? So as you can see, if we have no error, it will be like exit code 0. Otherwise, there will be some different exit codes. There will be some list of lines. Okay, this line has this error, and just like C++, this something we are not probably talking in this class, but the compiler doesn't give you exactly accurately the error where you have, right? Remember in C++ we've seen the similar situation, right? It sometimes points to line 15, but actually the error is located in line 13, right? It will be similar here, so you'll not exactly pinpoint the problem, but it will be listing the a lot of errors if you have any. Now let's look at, and also there is a terminal tab. This tab is used to communicate with the board. As I said, remember that once you are done with the program, you compile it, and then you have to download this, right? You have to communicate with this board. The downloading means what? You basically use some instruction to actually download it here. I'll show you how, okay? Now, let's look at a little bit more detail about what we are talking about here, okay? Now, there are 2 things. Number 1, how do you start? We have the board with us. You have to connect the board with the PC, right? That means physical connection, right? There should be some physical connection. How do you connect? We need to connect these 2 lines. These 2 serial, these are the serial connectors. We'll show you the image here. And also we'll power it up, right? There is an adapter. Use the adapter, we'll power it up. So there are 2 different things to activate this board physically and connect it with the PC. Number 2, we open the assembler, right? As I said, we have an assembler which is called ASM IDE. If you go to the lab, you see that's already installed in every computer. So you just click from the desktop, it will open. And then we will open an assembly program, right? Or maybe we'll open, or maybe we'll just start with as a new, whatever it is, okay? But remember, no matter what file it is, it will have an extension of .asm, because the assembly file will have the same extension always, okay? Now, a lot of times we write from the scratch. Sometimes we modify it based on what is the lab, or sometimes I write some code for you. You have to write the remaining part of it, okay? Some section of it, right? I think this is pretty similar what you have done in C++, that you already were given a code. You probably have to modify something, or you probably have to start from the sketch. That's that's something we'll be talking about in the lab. One will be starting the lab. It's probably pretty soon. And then this is actually the program. But remember, as I said, once we compile it, if there is no compilation errors, right, you'll have an object code generated, right? Again, object code is actually a file. I'm saying you will have an object code for every single instruction you have written, right? Every single line. Let's say you have 50 lines. That means there will be 50 lines of object codes, right? Which will be inside a file, right? Everything is inside a file. Now that file will have a different extension, right? but that will be under the same folder. Now, once you compile any file, there will be two separate files generated for every successful compilation. Okay, now, you have an ASM file. You compile it. Everything is right. Then there will be additional two files generated. Now, one file will have an extension S19. Do you see it? And this is called object code. Okay, this is actually called the. We sometimes call it object code, sometimes call it object file. But just to make it generic, just call it object code. Okay, there will be a different file called LST file. This is called a list file. Okay, but all this extension will have the same file name. Let's say your file has a name like my first file. You see what I'm saying? So you started with a program which is called myfirstfile.asm. So once you compile it, there will be two additional files generated. One will be myfirstfile.s19. Okay, and another one is myfirstfile.lst under the same folder where you have the initial file. Okay, meaning the ASM file. Now, once you have these files, this is actually the object code, meaning the one that we have with the S19 extension. This file will be actually downloaded into the Fox Trainer board, meaning because at this point everything is actually in your PC. Okay, because you wrote the program in ASM, you compile it, everything in your PC or in your flash drive. Okay, then you actually have to download those files into the Fox Trainer board. That is the next step. To download that, what do you do is, we actually go to the terminal tab. Remember, there is a terminal tab at the bottom. Okay, we go to the terminal tab, we write some instruction there. I'll show you what actually you need to write. Okay, those are called command line instructions. So you basically give some command, okay, to the program or to the compiler through the terminal window, and then it basically executes those instructions. Those are called command line instructions, and then based on your instruction, you basically will be able to download, okay, that program. Okay, so this is actually what we do. We basically, do you see the word load here? I made it bold. So you actually go to the terminal window, you type LOAD, and then press and enter. And then you go to the menu. Look at this. There is a menu, right? I'm talking about the menu here. Okay? You go to the menu, you click build, a pop-up window menu shows, okay? And you will see there is a option called download. Click the download. Automatically it gets uploaded. Okay? We'll show you also some images probably. That probably will help you understand. Okay? And then once the downloading is done, then we actually run the object code. Because again, now we have the object code in the memory of the Fox Trainer book, right? So we are ready to run. Now what we do is, we just run using the pretty much similar instructions. Okay, I'll show you what we need to do for running. Now let's go over all these steps a little bit more detail than what you have just talked here. Okay. Now this is actually the step one. In the step one, what do you do? You will have two serial connector here. Okay. Now when you go to the lab, you will see with every machine there will be serial connectors like this. And the serial connectors are actually numbered. If you go to the machine, you will see one of the serial communicator will be written as number one, and another one will be numbered as number 2. So number 1 most likely goes here, number 2 most likely goes here. In some PCs, that's reversed, so if it doesn't work, then we flip it. But in general, the number 1 should be going here, okay? Number 2 should be going here. So there are 2 serial communicators, okay? Serial connectors. And this is where we connect the power, so these are the 3 things that will be connecting. Then step 2, we open the SM, we click the SM ID to open the window. Now at the beginning, when you open the window, it will be exactly just like this one. It will be blank because there is nothing written, because you have not written anything yet. Okay, there are 2 tabs here. Those will be there. Okay, one will be the messages tab, and other one will be the terminal tab. Okay, now once we are done with these, meaning we just opened it, we just clicked it, we opened the software, then we actually open an assembly program, right? Let's say we are probably trying to modify. Now what do? We go to we click the file, right? Once we click the file, we basically go to the open, and we probably will be browsing from our, from our computer or from our flash drive, which will be already given to you, something like that. You'll open it, right? Probably you're trying to modify something. Now once you open it, you will have something like this one, right? As I again said, you will have some program which is already given to you. You're trying to modify something, right? So you'll have something like this, which is an assembly file. Remember, we always work with the assembly file, okay? But once we run it, we'll have 2 additional files generated, right? Now, let me show you how you actually run it. Now, so before you run, you first compile the program, right? That's how exactly you did in C++. Once you are done with the writing, you first compile it to see whether your program has some errors. Okay? Now to compile it, what do you do? It's very easy. Step 5, we actually go to the build. Do you see build here? We go to the build, we click the build, and once you click the build, you will see there are 2 different options here. So you will actually click the assemble. Assemble is actually compiling here because you are assembling the program, okay? Now once you assemble, do you see some information here? This is exactly what you will see if your program is running, compiled or assembled correctly, okay? You will see the dates, names, and total error 0, total warning 0, exit code 0. That means your program has been assembled successfully. There is no error, okay? And also, once it happens, that means for this program, there are 2 files generated, right, under the same folder. One file will be called an object code, which will have an extension S19, and another file will be called a list file, which will have an extension .lst. If this happens, meaning if the program ran successfully, the compile I should not probably say ran. Program compiled successfully or assembled successfully, you will see these messages. This means there are 2 additional files already have been generated. One with the extension S19 with the same file name, and another will be with an extension LST with the same file name, okay, under the same folder. Now, let's say we are done with the assembling process, okay? We're done with the assembling process. Let's say once we are done with the assembling process, what we have right now? We have our program written, which is a correct program, let's say, and we also have compiled it or assembled it, and then we have 2 additional files generated. One is the object code, which has an extension S19. Another one is a list file with an extension LST. But all these files are still located in our PC or in our flash drive, right? The next step is we actually have to download that file from PC to the Fox trainer board, okay? Oops. Now, how do I download this? To download this, I actually go to the terminal window, okay? I go to the terminal tab, okay? This is called the terminal window. Once you click the tab, then you will see some prompt, okay? Just like, you understand the prompt, right? The cursor will be blinking so that you can type in some command line instruction, okay? Then you will type LOAD, load, and press and enter. Once you do that, you first type load and press enter. Do you see I wrote here? You first press type and load and enter, and then you click here to the menu, okay? You click here, and you click at the download. That's the 2 step you have for loading, meaning the downloading the object code, which is actually the S19 file, to the Fox trainer. Okay? After this step, if this step goes right, that means your program will be successfully loaded. So you will see something like this. You will see loading in progress like this, because you just have wrote load and press and enter, and you went to the build, and you basically click download, That means your program is being loaded into this board, Fox Trainer board, right? That means program is what? The object file, object code, right? With the S19 extension. Now, once you are done with these, that means your program, the one that you have written, the object code of that program is actually waiting for you in this machine, in the Fox Trainer board, for you to run, right? Now, the next step is you'll be running the file from here, from the Fox Trainer board. Using the terminal window, you have to write something, type something, right? How do you run it? To run, you again go to the message, go to the terminal tab, and you will type that blue instruction. Do you see that blue instruction there? You can see the Fox Trainer board. So, blue instruction here. The blue instruction is actually, look at this, what do we have in the blue instruction? We just said G, and then there is an address. Do you see there is an address? G000. That's an address, right? In hex, right? Now, what this address actually means. See, if you go to each and every program, even when you will be typing or you will be modifying, you will always see a line like this. This is not an instruction, okay? These are called directives. We'll talk about directives soon, but this actually means ORGD000. This actually means this is where your program started. See, you have a bunch of memory locations, right? You probably will not be using all the memory locations in each and every program, right? You'll be using probably some of it, right? You will have to start from somewhere. It doesn't mean that you always have to start from address 0000, right? You'll be starting from somewhere else. We'll also explain why, but you'll be starting from somewhere else, right? Let's say this means your program actually has started from this address. That will be also always given in the program, okay? This line will be always there in the program. And this line indicates actually where your program started. From this line you see the program has started from D000. That means when you run the program, you have to tell G, then there is an address, and this address must be matching with this address. I'm saying both of these addresses should be matching. Because you have written program starting from address D000, and now you are telling your assembler to start executing the code starting from this address. And you just press an enter. G actually stands for go, but don't write go. I'm saying it's just G, okay? So G and then address, okay? Now, this is what you will do, and once you are done with this, you will see the output. Again, we don't know the output yet, but it depends on the program, right? Because some output will be showing up in the terminal window, right? Some of the cases, probably in the next semester, you'll be building a circuit in the breadboard, right? And once you run the program, you'll see some changes in the circuit. Maybe there will be some LEDs, right? There will be some displays. You'll see some changes there. But whatever it is, you'll see the output once you run it. Okay? Now at this point, since this is the very first lab we're going to start, we are trying to understand how we basically load, how we run, how we do different things, okay? But here is another example. Let's say if in your original program you see something like this, ORG0000, that indicates that your program has actually started from 0000 location, right? Then your run instruction should be this one. Do you see the changes? Because in the run instruction, you always indicate the address where the program has started. And how do you know it? You will know it from ORG instruction. I would say ORG directives. If you look at these, you will know exactly where the program started, and all you have to do is when you run, you have to mention that address in the instruction. So this address will be varying based on the program, right? So make sure you see and use that instruction. Now, once you run it, you'll see the output in the terminal window, or you might see some changes in the circuit. I have not mentioned that because most of the programs we'll be doing in this class for this semester, you'll have all the outputs in the terminal windows. Okay? So most likely you'll see everything here, but in the next semester you'll see some different outputs in the circuits, some changes in the displays or LEDs, something will be running, you know. So you'll see plenty of things. Any question here? If not, see, This is the first time we are exploring this sort of labs, and I think none of you have done it before. So that's why we want to understand almost every single detail of this lecture, okay? And we also have a pre-lab 1 quiz, where we have to get at least 80% to start the lab 1. Now let's go to the quiz section. I know that you are also working on some other quizzes, but most of you are done with probably most of it except the sample test. So let's go to the quiz section, and let's do the pre-lab 1. All the questions you will have in this quiz is actually based on this lecture, okay? But some of the questions you have to actually understand it to answer the question, okay? It's not exactly directly from here, but all the information you have in the lecture, okay? But make sure you do it so that we can start the lab. Hopefully we might start it next class. That will be the first lab. It's a very easy one, but it's it's mostly designed to understand how the lab works. Like, what do you see here? How to load, how to download, how to write, how to compile, meaning assemble, or how to run the program, how to see the output, all those kind of things, okay? Let me stop the presentation here so that you can do your quizzes.